Like till now, here, I'm writing it here, wait. Okay, here. Suppose here, I'm writing any variable. Suppose here I'm writing I is equal to 0. And any syntax here I'm writing. Any syntax does not matter. I is less than 5. And I forget to write here colon. Generally, you know, see here, colon is there, no? And suppose here I need to write this one. Print I. Suppose here I'm doing this one. I is equal to I is equal to I plus 1. Suppose here I'm just writing. So it is there. It is working perfectly now. Now I'm making certain mistakes. See here, I'm just making it up to here. Okay, here. Yeah, it is showing certain data error. It is showing certain error. Error it is there. No? So here it is showing certain indented error. Means certain error, the point is that. So I have to make it correct. Now see here, I'm just making this. If I run it again, it is making okay. Now I'm making a syntax error again. See here, I had to just remove this colon. It is here, it is showing me certain error is there. Syntax error, it is there. Invalid syntax. And in many more places, you can see like you are getting certain type of errors. Because when you work, suppose here I'm just writing print x is equal to any value. Suppose here I'm having x is equal to x. Let's take it. Let's check it out. It is saying certain data that certain you are not having x. So the point is here that we are getting the errors, generalized error, and you had worked a lot. You also know that when you work, there are a lot of errors. Generally, we call it a syntax error to correct the syntax error. Now, the point is here that one is type of a syntax error. Certain time what happens? Certain time we get name error, divide by 0 error. Wait, let me tell you. Suppose here I'm just making a is equal to 10. Okay, and here I'm doing a divide by means 10. Means 10, it is there, na? A value is 10. So here I'm just writing, okay, let me take it out. Print, simple only. Print a divide by 2, suppose. So it is 10 divided by 2. Okay, it is okay, it is working. Now what I'm doing, the same thing which I'm saying it here, a divided by 0. A divided by 0. So here it is saying certain error it is there. Okay, it is working perfectly. So the point is here, division by 0. So here it is saying certain error is there. If I check this statement, I say that my syntax are correct. There is no problem with the syntax. The way here I'm writing, the similar way here I'm writing. Divide sign is correct, A is correct or 0 is correct, does not matter. Because this is also certain variable, this is also a number, the correct sign of division I'm using, everything correctly I'm using. But still it is showing certain error. Okay. And it is showing, if I read here, division by 0 error. So the point is here that there are certain statements when we work here. So the statement I'm writing, they are correct. But when I'm running it, then they are showing the error. But statements are correct. Nobody can say that statements are wrong. So here it means the error is coming at the runtime. It is not coming at the time of writing or compile time. Means all the syntaxes are correct, but it is showing at the runtime when I'm executing it, then it is showing, okay, it is division by 0. It means you are dividing the data with 0. Getting? So if I'm dividing anything with 0, that causes the runtime error. Runtime error. Rest of things are correct. So see the differences. One is syntax error and second is the runtime error. Syntax errors are generally you are making a mistakes, colon, comma, not putting the variable, bracket close, you had forget. They are the syntax error. But certain time you are doing everything correct. Everything is correct. But at the runtime, it is making the error. But you are saying, ma'am, syntax is correct. That is also, we call it a runtime error. Runtime error. So there are certain runtime error which occurs at the time of running only, but the syntax is okay. How to handle it? So you can see here, one is 0 division error. It is showing division by 0. Here it is saying you are dividing any number by 0. The point is here, you cannot divide any number by 0. Or here I am saying, suppose 25 by 0. You cannot divide any number by 0. No, it is not. Because if you divide any number by 0, it will go to infinite. Infinite. So that will, you cannot do it here because it will go infinite. So what is the answer there? Nothing. That's why the syntax are correct, but runtime error is there. So this is a division by 0 error. Whenever you are dividing any number by 0, this is not acceptable at the runtime. Second thing, and you can see how it is just giving you the error here abruptly. It is closing the program abruptly. It is putting it here. You are dividing the thing by 0. If I show you certain more, like see here, this one. One is divide by 0. Another one is, see here, this one. See, suppose this is 5. It is not a 5. It is the string. Actually, it is the string. Plus 7, integer. Okay, you're already aware with the code is a string and it is integer. You are adding. Everything is correct. Syntax is not problems. Syntax is okay. But when you will run it, it will say, okay, this is a string and this is an integer. How can I add string with integer? So that is a type error. See here, type error. It can only concatenate string to string. It is saying you cannot put it string and integer, just make it string, then it's okay. Now it is okay. But if you are adding integer and string, then it is not accepted. It is a type error. It means you have to do the typecasting. You can do that also. Means both should be string, both should be integer. But one integer, one string is not acceptable. So you can see the type of the error. So your syntax are correct in both of the line here, but your runtime errors are occurring. Okay, runtime errors are occurring. We call it here exceptions. Such type of problem, we call it exceptions. Whenever your syntax is correct, but when you run it, at that time it is showing different types of error. 0 division error, type error, and certain more name error, and certain more errors are there. So what we can do here, we call it collectively, technically, exceptions. The same exceptions like happens in other programming language also. Like if I say, maybe some of you maybe are aware with C, C++ or Java, maybe. I don't know. But there also we do work with the exceptions there, okay, in those languages. So these languages, any languages have the correct syntax, but at the runtime, it is making certain mistakes. So it is closing the program abruptly, okay. Now, what is that exceptions? Exceptions can be defined as unusual condition in a program resulting in the interruption in the flow of program. It is closing abruptly. When an exception occurs, the program stops the execution and thus the further code is not executed. Therefore, an exception is the runtime error. Exception is a runtime error and are unable to handle the Python script. Means whatever you are writing the command, once it is stopped, it will not go further. Okay. So an exception is a Python object that represent the error, a kind of error which happens during the runtime. Okay. So here Python provides a way to handle the exceptions so that the code can be executed without any interruptions here. Okay. So there are certain type of exceptions such as zero division error, where you are dividing the thing by zero. Name error. It means certain name is not found. That is a name error. Indentation error, certain input-output error, and certain more errors are there. Runtime errors. So the point is here, exception happens in any of the programming languages. And here you can see line number 4. This is divided by zero division error. And you can see it here, suppose this one. It is, suppose I'm putting here number. What I'm doing? 8 plus number into 2. It means 8 plus number into 2. So where is the number? Somewhere I had defined the number. No, nowhere I had defined the number. Either I should give it 10. But when I checked it out, I had not find out any number. So it will generate the error. It will generate the error. That name error, it is not defined. Okay. Or okay. Or suppose this one. I'm just adding the string plus integer, so it is showing the type error here. Okay. So these all are certain type of exceptions. Now we can do the exception handling. Exception handling. So to handle such type of exceptions, there is a way to handle it. And the code which we use here to write the exception handling, that is try except. The keyword is there, try. Here I am having certain statements, and here at the below I have to write except. Okay. And here I will be handling the statement, and here I can give certain print statement. Here I have to handle the exception object, that what is the kind of error. And here I can just put it. So the point is here that this is a try except. This will allow you to handle the statement. This will allow you to handle the exceptions, which are runtime. Maybe means I can say, like suppose here I'm just writing, let me take it, 25 divided by 0. Suppose, let's take it. So it will generate the division by 0 error. So we can handle that exception here. That if the things are division by 0, just to print it, what is the error here? The same try except earlier when we used in Java, maybe some of you have, so there we are used try catch. Try catch block is there. That is same, similar, just like here. So here, no need for that one, just to come to try except only, because here we are using the Python here. So you can see this one, see this statement now, one by one. This one. Try except block, inside it I am passing the statement. Now I know, suppose here I'm just putting divide by 0. So if I'm running it here, so maybe a possibility it will just throw the runtime error, 0 division error. So here it is saying except 0 division error. 0 division error as error. So here, this is a way of writing that, okay, if certain mistakes we can make it here, means at the runtime, certain error could be happen. Kindly handle that error. Do not close the program abruptly. So it will just check it out. Try except, what could be the error? 0 division error. As error means, what is this as error? As error means I'm creating the object. I'm creating a small nickname of this 0 division error. This is the way of making the small nickname of this 0 division error as error. And here inside the print statement, we are saying, okay, handling runtime error. And just to see the description of the error, this error. This is the style of writing. So here it is saying when it will run. So it will just cause the error, 0 division error, handling runtime error. It is saying division by 0 error. So here this line is coming as it is with this one. And this error, this error is just coming by division by 0 error. So here from here, it is just taking this error, 0 by division error here. Okay. So because this 0 division error, it is thrown here and captured here in error object. So this is the style of writing the try except block here. Now see this one. Suppose I'm writing any statement. This is the actual statement. Now here I'm writing any variable. Suppose here I'm just writing 8 plus m into 2. So it will start looking for this m also where the m is defined. So either I should put here m is equal to any value 80, any value, suppose. So then it will not generate the error. So what we can do, we are just putting this statement here into the try catch. Try, because maybe a possibility this statement can generate certain runtime error. Try except keyword, these are the keywords, and inside it, we are saying maybe possible name error can come. So that's why we are saying just handle the name error. Maybe a possibility at runtime name error can happen. Try except name error as error. So this I'm making the small nickname an object of this name error. And here I'm just giving it here during the print statement that kindly make the description of it, that what is the error here. Just describe in your own words. So here handling runtime error, and name m is not defined. So from where it is getting name m is not defined here? From here. It is just passed here into the print statement from name error here, this one. So the point is, if I'm writing such statement, so either I should write it here, suppose. So then if suppose I had written m is equal to 80 and then 8 plus m into 2, it will work fine. It will not give you any statement just like this one. No, because you had given 8 plus m into 2. It means your m is already defined. M is there, so it is there. So it will simply take 8 plus 80 into 2. So the point is there. The point is there that this will not generate any error. If you had provided the m value, nothing will come. But maybe by chance you are doing certain work and by chance it is in between certain missed. So it will just show you, okay, m is not defined. So it will just say m is not defined. So we are handling it. We are handling it with our own words. So there is a try except. Do not, if you are not writing anything, still it will stop. But this is the best practices to work. Try except wherever we are thinking there could be a runtime error. The simple one, you can see it here now, this one. I had created a function here. Inside it, I'm just passing a, b, any value, and here a divided by b. Maybe b could be 0 or 10 or 20 also. But maybe I had passed somewhere b0. So it will take it. So 100% if I pass this b0 divided by 0, so it will just throw the division by 0 error. Now, because I know that, so there could be possibility whenever I'm dividing this number by a divided by b, maybe possibility somewhere I can just put it b0. So why not to put it here into the exception? So here I'm just putting inside the try catch. Try except. Try except, here I'm putting division function because if anywhere I had divided a by 0 somewhere, so it will throw the error. It will throw the exceptions 0 division error, and there it will make the error object. And here it will just say handling runtime error, and inside it will say division by 0 error. So the point is here that we can work with a simple statement also, then try except, and with a function also. We can create the function and we can pass this function inside the try except, that kindly handle this function with a try except if in case anywhere I divided this a by 0. So it will simply stop the program easily and give 0 division error and could explain us that what is the error. So remember, try except will just handle the errors at runtime. Okay, so here, just a moment, wait. Okay, now see here one more thing. Now, with these statements, different statement you can see. So here I had just told, I had created a function. I had passed this function inside the try except, that if any possibility of any error, so just handle that error, just handle that exception with try except clause here, and just give that particular error here as error, and it will be explaining the data. Now, see certain more words. Try except. Already you are aware now for the exception. I'm adding one more word, finally. Finally. Finally will finally execute the statement. The point is there, if in the code there is no exceptions, if in the code there is no error, no exception, still finally will work with the exception, without the exception. See how. See line number 12 here. See this one now. Line number 12, 14, 15 now. Here, okay. I had created a divide function, this one. User-defined function I had created. Inside this divide, I am just passing the x and y. Okay, so every time I need to pass this x and y here. Now here, I'm just putting it into the try except block. So there could be division by zeros error. So here I'm just putting x divided by y. So anytime, maybe when I'm calling it here, I can just put this one also. It will work fine now. 25 divided by 5, it will work very fine. But by chance, somewhere I had given suppose 30, 0. So that will go here 30, 0. So here also you will be getting 30 divided by 0. So if you divide by 0, you will be getting 0 division. So in first, when you are providing 25 and 5, there will be no exception. It will work well. And in second case, when you write here, you are passing 30, 0, so it will throw the exception. Two cases are there. 25 divided by 5 will work perfectly. 30 divided by 0 will throw the error. Two cases. So even if you are putting 25 divided by 5, so that will not generate any error or exception, still this finally will be executed. And later on, I am passing 30, 0, which will generate the exception. Still, this finally will be working. It will finally will be working in both of the condition, with 0 error, without not 0 error also. Means nothing. If your code is perfect, there's no error, no exceptions. Still, this final clause will work every time. Okay. And later on, if your code is somewhere not working well, that is having the 0 division error, so it will show you finally. In both of the cases, it will just execute this finally block. Now see here. I had written it. Now I had passed 25. I had passed 5 also. (25) and 5. See this one. So 25 divided by 5 will be there. So there will be no error. It will not work. So what it will do, it will just print the result. So 25 by 5, it will print the result what? 5. You will be getting the 5. And also what it will do, it will execute this print also. Print result. And also it will run this finally statement. Executed finally clause. Executed finally clause. So both things are coming without any exception. Okay, everything is fine. The second time, I'm just passing 30, 0. So here, 30, 0. So it means you are doing what? 30, 0. So 30 divided by 0. So here, in this case, yes, division by 0 error will be there. So it will throw the exception here, division 0. Now here you are printing division by 0. So here it is showing you the division by 0. And here it will not give the result here because there is a division by 0 error. But also it is going to show you finally 100%. So it is going to show executed finally clause. So the point is here that finally clause will be 100% executed into the code, whether the exception is there or not. Second thing, this except will only run if your code has the exception, runtime exception, otherwise it will not. So you should know to handle the runtime exception, we can use the try except statement. And if anybody wants to use the finally, you can do that. This is like exception handling is for the knowledge purposes here. Okay, just for the knowledge here that how to miss. You should know like what is the try except, how the exception handling can be done. So basic knowledge of the exception handling should be there. Okay. So let's move ahead. This is not like every time, this is not like every time you're going to do this. There's no need to do it. Does not matter. Just only you should understand that what is exceptions and how to handle it with a try except block. The basic knowledge is required. Okay. Now let's understand the object orientation. That what is the object orientation? So here I can just use object-oriented programming technologies also. Object-oriented programming. So certain time we can call it object-oriented programming systems also, OOPS concept. Okay. Since like we are working in Python, so we should know what is the base of the Python actually. Earlier days, if I go back 40 years back, there was a programming C. C programming was there. Nearby in 1970, C came. Okay. So Dennis Ritchie was there. He invented this programming. After that, C++ came nearby approximately 80s, nearby after 10 years. And after next 10 years, approximately 92, here Python came here. Now, if I talk here, C programming particularly, in the days of C, if I'm making any project, so I have to write continuously 500 lines of code, continuously. And the major problem is from here to here, 500 lines of code I have to write it, or 1,000 lines of code for making a simple project. And there is nothing of the technique where I can make it easy to handle any problems. If in case, suppose any error happens, suppose anywhere I had missed semicolon, I had missed plus sign, maybe it happens. So it will show you 500 errors there. Because the point is there, we were in initial stage of C programming, and there we do not have much facilitated methods to work with the code here. Later on, improvement starts working there. A lot of people start working onto the improvements so that we can come up with these type of codes where continuously I'm writing 500 lines or 1,000 lines for the projects, and there's no proper measures of handling these codes. Later on, C++ came here. When we worked with the C++, here we introduced certain new concept in C++. Here we introduced certain modular approach. Modular approach means here we started created the functions. we started creating the functions. Okay, suppose, let's take it. Suppose I'm making a calculator. For the calculator, if I'm writing the code in C language, I'm talking about C. So for this calculator, continuously, I will keep on writing all the codes which are required to make the calculator, such as taking the value from the user, then making addition, then making minus sign details, minus sign lines, I have to write it, multiply sign lines, I have to write it, which will deploy the multiplication of the 2 data or 3 data here, and then division, and then many more functionality which are related into the calculator. But continuously I have to do. But here when we worked in C++ onto the same approach, so here we worked a little bit smoother so that we can start making the modular approach. And if we are making the modular approach, for me, it is quite easy to handle the entire code. If any error occurs, I can find out the errors very easily. So in modular approach, we started making the method. And this method itself is the functions. Okay. So here we created the functions or the method to make the addition. Then we write another function to create the subtraction function. Then I had written another lines of code, but they will be inside the multiplication function or method, you can say. So it means I had used the modular approach so that I can make all the modules separated. Add is separated, subtract is separated, multiply is separated, divide is separated, another log and other functionalities are separated. So one can see here continuously line of code I'm writing, and here I'm using the functions to handle the one type of code in one function only, right? Now this is one. Now the point is here, we also took more approaches into the area of C++ to make this data, because the data is there inside it. So here certain data are there. I can say here A is equal to B is equal to C is equal to, the data are there, A value, B value. They are inside the add function. Here also certain A, B value, C, D values are present here. So they are inside the subtract function. So why not to make this data, A, B data, C data, little bit more protected, because the data is having actual information. Why not to make this data protected? So to make the protection, what we did, we created a class. So here inside the class, we had written the function. And inside the function, these variables are there. Variables means data are there. A, B, C data, which are holding the actual value. So here class concept, class calculator, inside it addition, subtraction, multiplication, division functionalities we had written. And inside this function, these variables are there, and variables are also inside the class also. The point is here, with the help of class, we provided the protection to the data, A, B, C data, or the other variables which I'm using within the functions here. So protection is the major one. How to protect the data? So to protect the data, we provide the classes here. Okay. So it means we are giving encapsulation. Encapsulation means whenever we are writing the classes, whenever we are talking about the classes itself gives the protection to the data, which is itself known as the encapsulation. We are capsuling the entire information into the class so that entire person cannot directly hit in my data variable. No, with the help of classes, that is not possible. So one said, okay, how can we take this data addition or subtraction? How we can do that? Because suppose as the user, I am there, I am a programmer. So suppose I want to interact with subtract function, addition function. How can I work? Because you had created this class calculator, but how can I access the subtraction and addition functions? How can I take A, B, C, D variables data? So you are not directly accessed. You are not authorized to directly access with the help of class. You have to follow the approach. Okay, you have to take the approach, otherwise you cannot work. So here what we did, we started making objects of the class. So one says, no, directly you cannot work. If from here you are just commanding A, B, the data is inside the A and B, or directly you are saying, okay, come subtract function. Suppose here you are writing subtract function. It will not allow. No, you cannot do this. You can hamper the data, A, B, C, D data, you can hamper it. There is a proper methodology of interacting with A, B, C, D data, or the addition, subtraction, multiplication, or any other function name here. You can do that. Okay. So here, now we need to interact with this add function or subtract function. Okay. So what we did here, we created the object. Means here we created the object. So how? Suppose this class calculator is there. So it says, okay, if you want to interact with A, you want to interact with B, or you want to call the add function. Directly you cannot call it. You have to make the object. So how? What is the name of the class? Class is there. Calculator. So what you have to make? You have to make the object here. So here, how to make the object? So it says, just create the object. So here, suppose I'm making calc is the object name of the class calculator. For the class calculator, I'm making the calc object. Now this calc object will interact with A, B, C, or A. So here I can write calc.A. Now only it will show you the data of A. Or if I'm writing here calc.B, now only you can interact with B. Or if you want to call the calc function, add function, so you have to write calc.add. The point is there that it says that if you're working with the classes directly, you cannot approach it. You have to make the object of the class. You have to make the object or instance of the class so that you can work with the variables and the functions. Otherwise, directly you want to say A, B, or add. No, these are not possible. So it means we are giving the protection to the data that directly you cannot access any variable or the function inside any class. You have to follow the protocol. You have to create the object or instance of the class. Then only you can take that. Okay. So here, now I'm taking certain new terminologies inside the object-oriented programming here. So remember, later on, the similar concept of C++ has been captured by the Python also, because Python is based on C. Okay, Python is based on C++ here. Okay, because if it is C++, here the class concept is there. So here comes the Python, and Python has all the features of C++. So whenever we talk about the class, so it means we are talking about the object-oriented programming technology. That's why we call it OOPS, object-oriented programming technology. And here, this class concept is available into the Python. So whenever here I'm making a class is a keyword here, class calculator. Class calculator is there. Okay. So here inside any class, you should know what are the components inside it here. Inside the class, if I say simplified way, here we can have the variables like A, B, C, D. So here technically, because it is a OOPS concept, so technically we do call it a class, and here inside it, the variables which are A, B, C, D are known as the data. and they are member of the class. So we call it data member. And these data members are, in simple term, they are the variables. But we collectively call data member because they are the data and actually they are the member of this class. Second thing inside it, we can have the functions. If you know you had created certain functions, so the same functions are here, but technically we do call it here as the member functions here. We call it as the member functions. They are the member. So we call it a member function. So whenever we do create any class, so there are data members and the member functions here. Okay. So this itself is object-oriented programming. Now suppose here I want to write a simple calculator. So what I can do, I can use here data or member here. So I can take A, B or C. So A inside it, A I can put, suppose here I'm writing A is equal to 10, B is equal to 20. Okay, and C is a variable which will hold the data. So they are the data members. How to write the member function now? Member function or simple function like you had worked. So here, like the simplified way, you had used in a very simple way here I'm showing you. Addition. And inside the addition function, you can just take this one, A plus B, you can do it. You can hold it into C variable, you can do it here. And you can just print the C. This way, I'm showing very simple way here. Okay, suppose you want to write any other function for the subtraction, one can write here DEF subtraction. Okay, so many more keywords we'll be using slowly. C is equal to A minus B, print C. So the point is here that here I'm writing the function of addition, here I'm writing the function of subtraction. I can write the function of multiplication and division. So in this way, we do write the code into the class where all data members, A, B, C, D, or function addition or subtraction, everything is safe. Everything is safe. Okay. Now, how to call it? How to call it? Because directly I cannot access. I'm not authorized to access it here. So what I will do it here, I need to create the object. So simply I will just write C A L C. I need to create the object. Otherwise, directly, if I write here A, it will not show me the value. If I write B, no. If I C, no. I need the protocol of creating the object-oriented programming technology where I need to create the object. So calc is the object I can make, and here I have to write the name of the class, calculator. Okay, and then I can write here calc.a. It will show me the value of 10. Calc.b, it can show me the value of 20. Suppose here I want to call this addition function to work. So simply I will write it here, the statement. I'll just write here calc.addition. Simple way. And now it will start working. Calc.subtraction. It means every time I need to call this calc here every time. This itself is the object of the class, or this itself is the instance. This itself is the object or instance, this calc. Instance or object, then only I can interact with the data member and the member function in a protected way. Okay, so this is a way of approaching the data member. Directly you cannot approach. Okay, so that is a way. So actually, remember in OOPS programming, object-oriented programming, we need to create the object to access the data members and the member functions. Directly, I cannot access anything. And whenever we are talking about the class here, so it means we are talking about the object-oriented programming technology, which itself is present inside the Python, because Python has been inherited from C++, and here inside the Python, all the properties are present which is related to C++. Just to revise it for 2 minutes, revise itself just to check it out, all these things yourself. So suppose here I'm writing a simple class in Python, how to write it. So there is a basic syntax of writing the classes here. So you can see here how to write it. There's a keyword class. We need to write a keyword class. Okay. And inside it, suppose here I'm just writing a class name, any class name. Okay. So simply here I can just write here car. Suppose here I'm taking a car. Simple thing only. Okay. So then here I can write two things I can do. Colon also I can write it here. So it will work. I can take in this way also, still it will work. Both are okay, does not matter. Okay. So this is a class car. Inside it, I can define the certain data members. You can define any data members here. Here. Okay. So here you suppose here I'm just writing here price of the car. Okay. One can just put any price here. Any price, that is up to you. Just and here I'm making the other data member here as the suppose here mileage. Only two variables here I'm making. So two variable, this is also a data member. Data members you can just understand as a variable in simple terms, but actually they are not variable, they are data members inside the classes. Okay, so these are two data members, and here I can just define any function also. Function means I will just call it a member function here. So how to write it here? Member function. Simplified here, I can just write def keyword, already you know. Def, I will just write here my function, only my function. Simplified function here, I'm writing it and I'm calling it here my function, and here, that's all. Okay, def function name here, and here I'm just using a print, a very simple line only. I'm just using that class. It is class car. A simple line here I'm using class car is there. Now, data members and member function I had created a simple one only. Later on, we are going to work with the heavy things here, but we are into the initial stages. Now, how to call it? So this class is created now. Okay. Now the point is how to work with it, means how to call it. So there we need to create the instance of it. So when I'm going to create the instance of it, I'll simply write here. This is the name of the class, no? Car here. So simply I'll just call object. I'm just creating the object or instance. Here. So what I'll write it here? I'm just writing C1 is equal to car. So it means car is the name of the class and C1 is the object or instance. Now next line, I want to see what is the price. Okay, or what is the mileage of this car. So I'll just write C1 dot price. So it will, if I write it here, it will simply show me 9999, whatever price is there. If I write here C1 dot mileage, so it will just show you the value which you had provided 100, suppose 100. If you want to see my function, so simply you will write C1 dot my function here. This one. So simply you can call it and it will show you print class car. So the point is here that you should know like how to create the object of the class. So this one is the general syntax of creating the class whenever we will be working in future. So class car, we can make class and the name of the car means name of the class. Not only car, we can make it here employee, student, or any other, whichever you need it. Play or any other. Okay, one we can do it. And then we can just define the variables and then we can define the member functions. And once it is done, my class is created. And now I have to create it, the object or the instance of the car. And then with the help of object, I can call the data member and the member functions. Without the creation of object, I cannot access any of these things. These are mandatory things. So these all works whenever we work as the OOPS technology. Whenever we call OOPS, Object-Oriented Programming System. So it is saying just you should work with a class which will make your data members and member functions protected with the help of class. Class will make your data encapsulated from any type of external data hampering or threat to your data. Once you create a class, your data is not at threat because nobody can access directly your data. One has to come up with a protocol of creating the object, then object dot data member, object dot member functions. So next time we are going to work with more of these classes here. Okay. That's all for today. Thank you. Thank you very much. Tomorrow I'm going to